So in this class we are going to discuss Newton's laws of motion. What are the Newton's laws? Newton's regarding motion gives three laws, and these are: the first law is the law of inertia. Second law is the F equals to ma. Third law is the action reaction law. Let us first know a little bit about these laws. First law is the law of inertia. What this law says? It says every body wants to maintain its state. If it is at rest, it wants to be at rest. If it is in motion, it wants to be in motion, unless an external force doesn't change its state. Second law says F equals to ma. It can also be written as cause equals to inertia into effect. It tells the effect of force on the body. In rotational motion, we can also write this Newton's second law as tau equals to I into alpha. This is our Newton's second law. If a body has large inertia, then it will have less effect due to the force. If it has less inertia, then the effect will be the more. Now the third law is the action reaction law. Suppose a body apply a force on the other body in the downward direction. As a result, this body also apply force on the body in the opposite directions. Now note this, these two forces don't cancel each other because these are acting on the different bodies. These are our Newton's three laws. So now we will get their definition. Now we will try to understand these laws. We will solve a problem by applying these laws. Let's see how we apply these laws. That's the main part. Everybody knows the definition, but very few people know how to apply these laws. So our main task is to apply these laws in the problem. Let's see the problem. Consider a wedge of capital mass M, on which a small block of mass M is placed, and it is resting on the floor. It is connected through a string over a pulley to another mass M dash. Now we have to find this mass M dash such that this block does not accelerate over the wedge of capital mass M. So our first step to solve the problem is free body diagram. Free body diagram. What is free body diagram? Free body diagram: isolate the body and show interactions on it. What type of interactions we are going to see here? Interactions are our force. So basically two kind of forces are acting here. One is our field force. Second is our contact force. Now see, only the field force acting here is the gravitational force. And how it acts? It acts always in the downward direction. Suppose this is a body of mass M, then gravitational force is equals to mg, and it is always acting in the downward direction. Second is our contact force. Contact force are our two types of forces. Two types of contact force are here in the problem. One is our contact force. One is our tension. Tension, it always acts along the string. Suppose a body is in this situation, then a tension is always acts along the string in the upward direction. Second is our normal reaction. Second contact force is our normal reaction. Let's see carefully what is normal reaction. Normal reaction, it is a contact force, and it acts if the motion of the body, it acts only when the motion of the body is constrained. It acts only when the motion of the body is constrained and the direction of this is opposite to the direction in which motion is constrained, and its magnitude depend on the degree to which motion is constrained. To understand this, consider a simple thing: a body of mass m, a gravitational force acting in this downward direction, and its acceleration is 9.8. So in this case, normal reaction is our 0. Now consider another case. This is mass m, gravitational force acting in this downward direction, and it is accelerating with a force of acceleration with a 2 meter per second square. Now in this case, the normal reaction acting on this is, let's say it is n. Now apply Newton's second law here. Acceleration is in downward direction, so force which is coming in the downward direction is taken as positive, and the another one which is in opposite direction is taken as negative.